This is your weekly dose of 3i Atlas featuring cryovolcanism, brought to you by the Sleepy Science 100 channel. Tonight we drift into the quiet cosmos, following an interstellar visitor whose activity is not fiery or violent, but soft, cold, and beautifully restrained. Now, let us settle in. Tonight we will glide through the surprising signs of cryovolcanic eruptions on a traveler from another star. Quiet releases of frozen volatiles, driven by unusual, metal-rich chemistry. Ice awakening, not in flame, but in gentle, cosmic breaths, painting the coma with subtle motion and structure. Let us begin by imagining a visitor from beyond our solar system, arriving slowly, silently, into our corner of the galaxy. This traveler has journeyed for millions upon millions of years, through darkness, through cold, carrying within it frozen memories of a stellar nursery we will never see. Recent observations of this wanderer, known as 3 Atlas, reveal something extraordinary, yet delicate, something that speaks in whispers of ice and metal rather than fire and heat. High-resolution images captured by the Jonaro telescope show faint spiral patterns, slender jets of gas and dust, emerging from the surface like breath, like a quiet sigh released into space. These are not ordinary jets. They are interpreted as evidence of cryovolcanic plumes, eruptions not of molten rock, but of icy materials, pristine volatiles awakening after eons of stillness, responding gently to sunlight, releasing pressure built over cosmic time. As we continue drifting through these quiet eruptions, watching frozen worlds exhale. If these slow journeys through sleep and space feel soothing or meaningful, you're warmly invited to subscribe. Liking the video helps us know these calm explorations are reaching you, and if you're still awake before you fully drift off, feel free to leave a single word in the comments describing how you hope to feel in the morning. Rested, calm, clear. Thank you for joining us tonight as we drift far, far out, exploring the silent beauty of cryovolcanism on 3i Atlas. Cryovolcanism. The word itself feels cold, volcanic, yet gentle. It describes eruptions where water or ammonia or carbon dioxide takes the place of lava. Instead of fire, there is ice. Instead of heat measured in thousands of degrees, there is the quiet chemistry of freezing and thawing, of pressure and release. On this distant traveler, something ancient is stirring. The surface of 3i Atlas lacks something that most comets from our own solar system possess. It has no protective dust mantle, no accumulated crust from repeated passes near the sun. This absence, this nakedness, allows something remarkable. The entire surface can activate, can breathe, can erupt, all at once, globally. There is no shield to suppress the buried ices beneath. Imagine the surface as an open invitation to solar warmth. Without a mantle, without that protective barrier, the sunlight reaches directly down into the subsurface layers, awakening volatiles that have slept undisturbed for billions of years. This global activation creates sustained eruptions, not just brief outbursts. but continuous, gentle releases of material. The pristine nature of this object preserves volatiles from its distant stellar nursery, the place where it formed, orbiting another star in another system long ago. And now, as it passes through our sun's warmth, for perhaps the first time in millions of years, those ancient ices begin to remember what heat feels like. The spectral data, the fingerprints of light, tell us something unusual. When scientists compare the reflected light from 3I Atlas to samples we have here on Earth, they find it matches carbonaceous chondrites. These are primitive meteorites, metal-rich, dark, ancient beyond measure, from the earliest days of our own solar system. If this interstellar visitor resembles these meteorites, then it is likely enriched in native metals, nickel, iron, embedded throughout, like grains of memory, scattered through ice. And here is where the hidden volcanic whispers begin. Metal grains, tiny fragments of nickel and iron, react with the sublimating ices around them. As the ices turn from solid to gas as they wake, they touch the metals, corrode them, oxidize them. This reaction, this slow corrosion, releases energy, releases gases. It sustains the cryovolcanic activity, not through heat alone, but through chemical processes, through catalytic dances that fuel ongoing eruptions. The metal-fueled silent eruptions continue, not because the sun alone warms the surface, but because deep within, chemistry is happening. Fischer-Tropsch-like reactions, where metals act as catalysts, generating additional heat, additional gases. The interior becomes a quiet factory of volatile production. Let us drift deeper into the coma, the cloud of gas and dust surrounding this traveler. The coma is unusually rich in carbon dioxide. CO2 dominates. In fact, the ratio of carbon dioxide to water is exceptionally high, around 8:1. For every molecule of water vapor, there are 8 molecules of carbon dioxide. This is strange. This is not what we typically see. Most comets from our own neighborhood exhale water as their primary breath, but this visitor breathes differently. Small amounts of water vapor, yes, but also carbon monoxide, CO, and even carbonyl sulfide, OCS. These trace whispers add complexity to the chemical signature. The outgassing, the exhalation, is dominated by carbon dioxide and carbon monoxide rather than water. This tells us about the formation conditions, about the temperature and chemistry of the protoplanetary disk. Where this comet was born, it speaks of processed materials, or perhaps a unique formation environment, colder or richer in carbon-bearing ices. The activity began early, remarkably early, even at distances beyond 4 astronomical units from the Sun. Beyond where Mars orbits, the brightness began to increase. This early awakening indicates that near-surface volatiles, highly volatile substances, were activating. There was no typical water ice sublimation dominant at these greater distances. Instead, the carbon dioxide, which sublimates at lower temperatures, led the way. Cryovolcanism explains this sustained brightness, without fragmentation, without the object breaking apart. Internal pressure builds as sublimating ices, deep within, turn to gas. The pressure seeks escape, finds weaknesses, vents, cracks, channels, and erupts through them, gently. The jets appear structured, spiral in form, suggesting multiple eruption points, active regions, scattered across the surface, breathing in coordination, or perhaps in rotation, as the comet spins. Each jet, a thread of another star's past, reaching outward. Post-perihelion images, taken in November 2025, after the comet passed closest to our Sun, show ongoing jet activity. The eruptions did not stop, they continue. The Hubble Space Telescope, the Gemini Observatory, captured the evolving coma morphology, watching as the cloud of material expanded, shifted, near perihelion. The coma expansion reached thousands of kilometers, a vast sphere of dust and gas surrounding the small, dark nucleus. The nucleus itself, perhaps only a few kilometers across, yet generating such extensive activity. As we settle deeper into this journey, let us consider the pristine memory drift. The comet's interior preserves volatiles, untouched, for billions of years. In interstellar space, cosmic rays, high-energy particles streaming through the galaxy may have processed the outer layers over eons, altering them slightly, but deep within, the original ices remain, fossils of another system. The internal chemistry drives eruptions, independent of surface sublimation alone. It is not just the sun acting from outside, but reactions happening within, a hidden source of energy and gas. X-ray emissions have been detected, faint but present. This suggests interaction with the solar wind, the stream of charged particles flowing outward from our sun. As these particles collide with the expanding gases in the coma, they excite atoms, causing them to emit soft X-rays, a glow invisible to our eyes, but revealing the violence, however gentle, of this cosmic encounter. The non-gravitational acceleration, the way the comet's trajectory changes slightly, more than gravity alone would predict, is influenced by these asymmetric jets. The eruptions push back, creating a recoil that nudges the comet's path. These trajectory perturbations are compatible with cryovolcanic forces. Coma dust grains, tiny particles, are ejected by the pressurized gas releases. The volatiles, as they burst forth, carry dust with them, entraining particles, lifting them away from the surface. These grains, driven by carbon dioxide and carbon monoxide outgassing, travel far. The volatile inventory has been retained over galactic travel timescales. Think of it. This object has wandered between the stars for perhaps 5 million years or more since leaving its home system, yet it still holds its frozen breath, its chemical treasures, ready to release them when warmth finally arrives. The high carbon dioxide abundance indicates something processed or unique in its formation. Perhaps the disk, where it formed, was especially rich in carbon, or perhaps chemical reactions. Early in its history, converted water into carbon dioxide through interactions with carbon-rich materials. Water ice grains ejected into the coma sublimate remotely, not on the surface, but 4,000 to 10,000 kilometers away, out in the cloud. This tells us that solid grains of water ice are being launched intact from the surface, and only later, as they drift, do they turn to vapor. Interestingly, no iron vapor was detected initially and in the early spectra. This is unusual for comets. Typically, we see both iron and nickel if metals are present, but here nickel emission appeared without corresponding iron. At first, scientists have hypothesized that organometallic compounds like nickel tetracarbonyl may be responsible. This compound, nickel bonded with 4 carbon monoxide molecules, can form at relatively low temperatures and releases nickel vapor when it breaks apart. As the comet heats and progresses, the imbalance normalizes. Iron begins to appear as deeper, hotter layers are exposed. The detection of cyanide radicals, CN, confirms typical cometary volatiles are present. These molecular fragments glow in the coma, excited by sunlight. Diatomic carbon, C2, also contributes to a faint greenish glow in the coma. This green tint, subtle, is a signature of carbon-rich comets. The low albedo, the darkness of the surface, results from dark, light-absorbing materials. Perhaps carbon, perhaps organic compounds, created through irradiation over the ages. Without a protective mantle, direct solar heating reaches the subsurface continuously. The global eruption across the entire surface layer has been observed. This is different from the acute outbursts we see in local comets, where a single active region suddenly releases material. This sustained activity is more akin to processes on trans-Neptunian objects, distant icy bodies beyond Neptune, that also experience cryovolcanism. The similarity to these TNOs suggests that 3 Atlas formed in the outer disk of its origin system, far from its star, where ices could accumulate, pristine and cold. These pristine ices, untouched for billions of years in the void between stars, now release their ancient contents. Let us pause and breathe with the comet. Feel the mantleless openness, the way the surface invites solar energy inward. There is no resistance, only quiet acceptance. The buried ices stir. Chemical reactions between metals and ices fuel the ongoing activity. The brightness, sustained over months, without sudden explosion, without breakup, speaks to internal reserves of volatiles and energy. Comparison has been made to Pluto's cryovolcanoes, Wright Mons, Picard Mons, those massive ice mountains suspected of volcanic origins, or to Enceladus, Saturn's small moon, where plumes of water vapour and ice grains erupt from cracks near the South Pole. Here, on this tiny interstellar body, the same principles may apply. Metal corrosion releases gases, sustaining the eruptions. The primitive composition preserves ancient stellar material from the disk around another star. The spectral reflectance, when compared to samples, matches Antarctic carbonaceous chondrites, the darkest, most primitive meteorites we possess. Aqueous processes, the presence of liquid water, even temporarily, are indicated. This suggests that at some point, perhaps during formation or perhaps during brief warming events, liquid water existed within this comet, altering minerals, corroding metals. The energy from metal oxidation powers the ice volcanism. It is a battery, slowly discharging as metals give electrons into oxygens in water or carbon dioxide. The jets, in some observations, appear oriented toward the sun. This makes sense. The warmest regions face the incoming sunlight, and those regions erupt more vigorously. An anti-tail, dust pushed sunward by radiation pressure, may also be possible, creating the illusion of material moving against the flow. There are hints in the data of heartbeat-like pulses in the brightness. These suggest rotational modulation. As the comet spins, active regions come into view, then rotate away, causing the brightness to wax and wane in rhythm. The non-uniform outgassing from these active regions creates the structure we see in the coma. This cryovolcanism broadens the diversity of known cometary behaviors. It has implications for understanding geological activity in extrasolar small bodies, worlds orbiting other stars that we cannot yet see directly. The lack of a protective mantle is due to the fact that this comet has never made repeated passes near a star. It formed, orbited quietly in the outer reaches of its home system, then was ejected gravitationally into interstellar space. This is its first close stellar encounter in millions, perhaps tens of millions of years. The activation of deep deposits during perihelion warming brings ancient material to the surface. Carbon dioxide dry ice, sublimation, initiates pressure buildup beneath the surface. The gas has nowhere to go except up. It finds vents and cracks and channels the eruptive material upward, outward. Dust entrainment in these gaseous plumes forms the visible jets we observe. The coma chemistry evolves as deeper layers are exposed. Each day, as more ice sublimates, fresh material from further within is revealed. There is even potential for prebiotic molecule formation in these reactions. Amino acids, sugars, the building blocks of life, might form where metals catalyze. Organic synthesis from simple carbon and nitrogen compounds. The metal-driven pathways differ significantly from water-dominated comets. In a typical comet, water ice is the main actor. But here, carbon dioxide and metal chemistry take center stage. The sustained jets challenge pure sublimation models where ice simply turns to gas from solar heating. Instead, a hybrid model, internal and external heating combined, is proposed. Observations from multiple telescopes confirm the jets. Multiple independent teams have seen them. This is not an artifact, not a mistake, but a real phenomenon. Preprint studies, papers submitted but not yet peer-reviewed, invoke cryovolcanism to explain the morphology, the shape and structure of the coma. Global activation across the pristine surface seems possible. The energy release from chemical alteration, from the corrosion of nickel and iron sulfides reacting with oxidizing liquids, sustains the activity for weeks, months. The Fischer-Tropsch catalysis, where carbon monoxide and hydrogen react on metal surfaces, generates additional volatiles, hydrocarbons, and alcohols that then sublime away. Unusual polarization signatures in the light scattered by dust in the cryovolcanic plumes hint at the composition and structure of the dust grains. The coma morphology shows a teardrop shape or irregular form depending on the viewing angle and the activity level. Post-perihelion contraction of the coma as activity begins to wane is now being documented. Ongoing monitoring by observatories worldwide tracks the eruption decline as the comet recedes from the sun, moving back toward the cold and the dark. This is a test case for extreme comet physics, interstellar weathering, the bombardment by cosmic rays and interstellar dust over millions of years influences surface reactivity. Perhaps the outer layer is more chemically active, more ready to react than freshly excavated material would be. This pristine TNO analog, a body resembling the distant icy worlds of our own outer solar system, is experiencing its first heating in an immeasurable span of time. The data we gather informs our models of extrasolar planetesimal interiors, the insides of small worlds orbiting distant stars. The metal enrichment came from the protoplanetary disk where this comet formed. Perhaps that disk was richer in metals than our own. Or perhaps the comet formed in a region where metals condensed more readily. Volatile retention over billions of years is remarkable. Think of the cold, the emptiness of interstellar space, temperatures hovering just a few degrees above absolute zero. At such temperatures, even the most volatile substances, nitrogen, carbon monoxide, remain frozen, solid. The eruptions expose unaltered deep material, giving us a window into the original composition of another star system's building blocks. The chemical products, unique to metal-ice interactions, include not just gases, but possibly complex organics, tholins, reddish-brown materials formed by irradiation. There are implications here for panspermia, the idea that life or its precursors might spread between star systems. If organic molecule can survive and even form on interstellar comets, then perhaps these travelers carry the seeds of life from star to star. Cryovolcanism is not unique to solar system moons. We see it on Europa, on Enceladus, on Triton, and now we see evidence on an interstellar wanderer. Small bodies in other systems retain the potential for activity even after being cast out into the void. And 3i Atlas reveals the diversity of interstellar comets. Each visitor from beyond brings unique chemistry, unique history, a story written in ice and stone and metal. As we drift now into the deeper current of this exploration, let us feel the quiet awakening of buried ices within ourselves, the gentle bursts from ancient frozen depths mirror the slow release of the day's tension. The metal-fueled silent eruptions are like thoughts, oxidizing, dissolving into stillness. Your breath slows, matching the pace of sublimation. Carbon dioxide molecules, one by one, leaving the surface, drifting into the coma. The subsurface pressure's soft release is your own, letting go of what you do not need to hold anymore. The cryovolcanic heartbeat in the void pulses in rhythm with your own, slower now, gentler. The primordial volatiles stirring to life are memories, surfacing, then fading harmlessly away. Ice volcanoes painting faint jets against the darkness like neural patterns, dimming as sleep approaches. The chemical reactions igniting cold fire require no effort from you. They happen on their own, as natural as the tides. The mantleless surface, allowing global breath, reminds you of openness, of vulnerability that is also strength. Deep cavities, exhaling eons-old gas, are like lungs, releasing carbon dioxide, welcoming oxygen in a cycle. Automatic and ancient, the metal grains, corroding in fleeting warmth, teach us that transformation is inevitable and gentle. The catalytic dances, driving quiet plumes, are beyond our control, and that is a comfort. Eruptions, as memories of distant formation, hold no weight. They are simply information drifting outward. Volatile treasures surfacing calmly are insights rising, acknowledged, then released. Subsurface rivers of gas emerging into space flow without resistance. The ancient interior, revealing its secrets, does so in its own time, at its own pace. As you will, reveal your rest when ready. Ice vents, channeling stellar history, are like breath, carrying the day away from you into the vast, forgiving night. The sustained glow from hidden activity is the faint light of consciousness, remaining just enough to know you're drifting, but not enough to disturb the descent. corrosion-powered cosmic fountains, gentle, tireless, continue without your attention. Jets as threads of another star's past weave a web that cradles you. The quiet violence of pristine activation is a paradox, intense yet soft, transformative yet peaceful. The Metal Ice Symphony plays in slow motion, notes separated by silence, by space, by the infinite patience of cosmological time. And now, as we continue to drift deeper into the mechanism, the hidden choreography of these ice volcanoes, we find ourselves exploring the relationship between interior architecture and external expression. Consider how the absence of a dust mantle changes everything. Most comets from our own solar system build up a crust over repeated passages near the sun. This crust acts as an insulator, trapping heat, trapping gas, allowing pressure to build until it ruptures, causing sudden, violent outbursts. But this interstellar traveler, arriving pristine, has no such armor, no such accumulated history of thermal stress. Its surface remains responsive, immediate. Each photon of sunlight penetrates, stirs the subsurface, without delay, without buffering. Imagine the surface as a living skin, porous, breathing, every square meter, capable of participating in the global exhalation. This is what allows this sustained, diffuse activity, rather than localized, explosive events. The spiral jets captured in those high-resolution images suggest something about the nucleus shape and rotation. Perhaps the nucleus is elongated or irregular, with specific regions more enriched in volatiles or metals. As it spins, these regions come into and out of sunlight, creating the spiral pattern in the expanding through the garden of space. The rhythm, the periodicity, speaks of rotation, of day and night, on a world so small that walking across it might take only an hour. Yet within this tiny realm, such complexity unfolds. Aqueous alteration, the evidence of liquid water's touch, tells a story of warmth, however brief, in the comet's past. When minerals come into contact with liquid water, they change. Iron sulfides, like troilite, oxidize, rust, releasing hydrogen sulfide gas, perhaps even hydrogen, which then escapes. The nickel-iron alloys also corrode, transferring electrons to dissolved ions. This electrochemical process generates heat, modest amounts, but in the cold vacuum of space, every joule matters. The water itself may have existed as thin films, coating grain boundaries, or as small pockets of brine, too salty to freeze, even at very low temperatures. These aqueous processes occurred perhaps during the comet's formation, when radioactive decay of short-lived isotopes like aluminum-26 warmed the interior, or perhaps during a previous stellar encounter long ago, before ejection into interstellar space. The evidence remains written in the mineralogy, in the altered compounds that now sublime, releasing their chemical memories into the coma. The Fischer-Tropsch-like reactions, named after the industrial process, convert carbon monoxide and hydrogen on metal surfaces into hydrocarbons. This requires a catalyst. Iron or nickel works well, and it requires pressure, and it requires temperature, not extreme heat, but warmth enough to overcome activation barriers. In the interior of 3I Atlas, these conditions may be met. Carbon monoxide ice, sublimating in the subsurface, encountering metal grains, hot enough from corrosion or solar heating conducted inward, might react, producing methane, ethane, perhaps even more complex molecules. These newly formed hydrocarbons are themselves volatile. They add to the gas production, sustaining the pressure that drives the cryovolcanic plumes. It is a feedback loop. Chemical reactions produce heat and gas, which allows more sublimation, which exposes more metal surfaces, which catalyze more reactions. The organometallic compounds, such as nickel tetracarbonyl, add another layer to this chemical symphony. Nickel tetracarbonyl forms when nickel metal reacts with carbon monoxide gas at relatively low temperatures, perhaps around 150 to 200 Kelvin. It is a volatile compound, a liquid at room temperature, but in the cold subsurface, it might exist as a solid or gas. When it decomposes, either from heat or from ultraviolet light, it releases nickel atoms, which then appear in the spectral observations as glowing emission lines. This explains the early detection of nickel without iron. The iron requires higher temperatures or is to vaporize directly from metal grains. As we contemplate this chemistry, this interplay of elements, we can let our own internal chemistry settle. Your neurons, firing throughout the day, now slow their tempo. Neurotransmitters rebalance. Adenosine, that gentle sleep pressure, accumulates, binding to receptors, quieting the arousal systems of your brainstem. The metal-driven serenity of the comet's interior mirrors the biochemical serenity, settling over your nervous system. The pristine buried breath of volatiles is like the deep breath you take now, filling your lungs, then releasing, slowly, completely. The cryovolcanic calm spreads through the comet's coma and through your awareness. Ancient pressure, built over millions of years, now surrenders to the inevitability of release. Just as the gas escapes through vents, your thoughts escape through the open spaces of near sleep. The silent jet harmony plays on without effort, without will, simply because conditions allow it. Your rest, too, will come, simply because conditions are right. The chemical depth peace of reactions occurring in darkness, far from any observer, reminds us that transformation happens, even when unseen, even when we sleep. Let us drift now toward the observational journey, the human side of this discovery. Astronomers around the world pointed their instruments skyward, coordinating observations across wavelengths across continents. The Jonah Raw telescope, named for a biochemist who studied the origins of life, seems fittingly named for observing an object that might carry prebiotic chemistry from another star system. The high-resolution images required long exposures or precise tracking, compensating for Earth's rotation and atmospheric turbulence. Each photon traveling across light years, then across our solar system, finally striking a detector and carries information encoded in its wavelength, its polarization, its arrival time. The Hubble Space Telescope, orbiting above our atmosphere, captured images free from atmospheric distortion. Its cameras, sensitive to ultraviolet wavelengths, revealed gases invisible to ground telescopes. The Gemini Observatory, with its adaptive optics, correcting atmospheric blur in real time, produced sharp views of the coma's structure. Multiple exposures, separated by days or weeks, showed evolution, jets strengthening or fading, the coma expanding, then contracting slightly. Each observation a snapshot in an ongoing story. Spectroscopy, the breaking of light into its component colors, revealed the coma's composition. Each element, each molecule, absorbs or emits light at characteristic wavelengths. Sodium glows yellow, cyanide radicals emit violet, diatomic carbon contributes green. By measuring these fingerprints, astronomers inventory the chemical species present in the coma. The intensities tell us abundances, how much of each gas is present, the ratios, carbon dioxide to water or carbon monoxide to water, constrain models of formation and evolution. The absence of certain species is also informative. The lack of abundant water vapor at large distances, the missing ion emission early on. These absences pose questions, drive hypotheses. The detection of X-rays required specialized instruments, satellites, carrying detectors sensitive to high-energy photons. These X-rays are so energetic, penetrate matter easily, but are absorbed by Earth's atmosphere. Only from space can we see them. The emission mechanism involves charge exchange, solar wind ions, highly charged, encountering neutral atoms in the coma, steal electrons, dropping to lower energy states, releasing X-rays in the process. The polarization measurements examined how light scatters off dust grains. Light waves oscillate in planes. When they scatter off particles of certain sizes and shapes, the oscillation becomes preferentially aligned, polarized. By measuring this polarization at different angles and wavelengths, we infer the size distribution, the composition, the shape of the dust particles. The unusual polarization suggests grains different from typical solar system comets, perhaps more irregularly shaped or composed of materials with different refractive properties. As we absorb these observational details, these technical achievements, we can appreciate the patience required. Observing runs scheduled months in advance, can be disrupted by weather, by equipment failures, by the comet itself, moving into unfavorable positions. Astronomers write proposals, arguing for telescope time, competing with hundreds of other projects. When awarded, they prepare meticulously, calculating coordinates, exposure times, filter selections. Then they wait for their assigned nights, hoping for clear skies. This patience, this careful preparation, followed by surrender to conditions beyond control, resonates with the journey into sleep. You prepare, create conditions, dim lights, quiet sounds, comfortable position. Then you must surrender, release control, allow sleep to come in its own time. The mantle-less openness of the comet, accepting sunlight without resistance, reflects the openness required of you to accept rest. The primordial eruption flow happens not through force, but through yielding to pressure that has built naturally. The corrosion's soft energy teaches us that even destructive processes can be gentle, slow, metal. Giving up electrons, dissolving slightly, is not violence but transformation, participating in a larger cycle, the catalytic quiet pulse of reactions, mediated by metal surfaces, shows us that presence can be enough. The catalyst is not consumed, merely facilitates, enables. Your awareness now becomes catalytic, present, but not interfering, allowing the reaction of waking into sleep to proceed. Let us turn our attention to the broader implications of this interstellar chemistry. If 3I Atlas, with its metal-enriched composition, represents a common type of small body from other star systems, then the galaxy may be filled with similar objects, traveling silently through the dark, each expelled from its birth system through gravitational interactions with planets or stellar companions. They wander for millions of years, dozens of light years from their home, before chance brings them into another system. The frequency of such visits is uncertain until the first interstellar object, Oumuamua, was discovered in 2017. We could only speculate. Now, with improved surveys, more sensitive detectors, we detect these visitors more regularly. 3I Atlas, discovered in 2025, follows 2I Borisov, discovered in 2019. Each interstellar comet offers a sample of another system's inventory, a messenger from the galactic neighborhood. The diversity, already apparent, suggests that planetary systems form with varied compositions, metal-rich, like 3I Atlas, or more typical, water-rich, like 2I Borisov. This diversity has implications for planet formation theories. If protoplanetary disks vary widely in their metal content or their volatile inventory, then the planets that form and the small bodies that remain will also vary. The composition affects everything: thermal evolution, differentiation, the potential for geological activity, even the potential for hosting life. A metal-rich comet with catalytic surfaces might produce more complex organic molecules than a metal-poor one. These organics, if delivered to a planet's surface, could contribute to prebiotic chemistry. The implications for panspermia, the hypothesis that life spreads between worlds or even between star systems, become more intriguing. If interstellar comets arrive regularly, and if they carry organic molecules or even more complex structures, could they seed sterile worlds with the building blocks or even templates for life? The survival of complex molecules through the journey is questionable. Cosmic rays degrade organics over millions of years, but deep within a comet's interior, shielded by meters of ice and rock, perhaps some materials could survive. The idea remains speculative, yet these interstellar visitors compel us to consider connections between star systems beyond gravity and light. Imagine a network of exchange, material, drifting through the galaxy over deep time, star systems, not isolated, but connected through wandering comets. The global surface sigh of 3I Atlas, releasing its contents into our solar system, becomes a gift of information, of matter from another corner of the galactic disk. As we drift through these cosmic implications, we can feel our own sense of connection. The atoms in your body were forged in stars that exploded billions of years ago. You are quite literally stardust. The oxygen you breathe, the carbon in your cells, the iron in your blood, all created in stellar cores or supernova explosions. Now, here, contemplating a comet from another star, you close a circle, matter, awareness, observing its own origins. The volatile memory drift of ancient ices, sublimating away, parallels the drift of your thoughts into the formless. Memories from the day surface briefly, then disperse like gas molecules into the vastness. The interior cosmic exhale of the comet, releasing what it has held for eons, invites you to exhale what you no longer need. Worries, tensions, the day's accumulations, let them drift outward into the night. The ice vent stillness, the quietness at the mouth of each vent before the next pulse, is the stillness between your breaths, growing longer, deeper. Now we explore the connections to other worlds where cryovolcanism occurs within our own solar system. Pluto, that distant dwarf planet visited by New Horizons in 2015, revealed a young surface in places, smooth plains of nitrogen ice, suggesting recent or even ongoing geological activity. Features like Wright Mons and Picard Mons are massive mountains, several kilometers high, with depressions at their summits, possibly calderas from collapsed cryovolcanoes. The mechanism might involve subsurface oceans of water and ammonia, heated by radioactive decay, achieving enough pressure to force plumes through the thick ice crust above. Europa, the icy moon of Jupiter, shows surface features that hint at subsurface activity, chaotic terrain where the surface is broken and refrozen suggests warm ice from below has intruded upward. There may be active cryovolcanism, though we have not yet directly observed eruptions. Enceladus, Saturn's small moon, provides perhaps the most dramatic example. Geysers erupting from cracks near the South Pole, spray water ice particles, and vapor hundreds of kilometers into space. The Cassini spacecraft flew through these plumes, sampling their composition, finding not just waters but salts, silicates, and even simple organic compounds. These plumes on Enceladus confirmed a subsurface ocean, a global sea beneath 10 to 20 kilometers of ice. Tidal heating from Saturn's gravity keeps this ocean liquid. The cryovolcanic vents at the South Pole connect directly to this ocean, meaning samples of ocean water are accessible without drilling. Triton, Neptune's largest moon, also shows evidence of past, or perhaps intermittent, cryovolcanism. Voyager 2 in 1989 captured images of geyser-like plumes, dark material, rising 8 kilometers high, possibly nitrogen gas and dust erupting from the surface. The comparison of 3I Atlas to these solar system examples highlights both similarities and differences. The sustained plume activity resembles Enceladus, though at a smaller scale. The metal-driven chemistry differs from the ocean-connected vents of icy moons. The pristine surface, without repeated thermal processing, resembles a trans-Neptunian object like Pluto, experiencing its first major heating, the role of carbon dioxide rather than water or nitrogen as the primary volatile adds uniqueness to this interstellar case. Understanding cryovolcanism across this range of bodies informs our search for habitable environments. Subsurface oceans kept liquid by tidal heating or radioactive decay or chemical reactions might exist on moons throughout our solar system and around other stars. These oceans, isolated from surface radiation, shielded by ice, could potentially harbor life. The vents, where ocean water meets the surface or erupts into space, are interfaces of particular interest, mixing chemistry from the deep with energy and materials from above. The sustained hidden glow of cryovolcanic activity suggests enduring energy sources not dependent on sunlight. This expands the habitable zone, the region around a star where liquid water could exist, to include locations far from the star where internal heat matters more than stellar radiation. Moons orbiting giant planets in the outer regions of their systems might be warm inside while frozen outside. This insight multiplies the potential sites for life in the galaxy. The tidal flexing of moons like Enceladus or Europa, the rhythmic kneading and by a parent planet's gravity, creates friction deep within the rocky core, generating heat that sustains subsurface oceans for eons. This is a quiet warmth, a subterranean fire, shielded from the vacuum of space by miles of protective ice. It suggests that life need not bask in the light of a yellow sun to thrive. It can exist in the pressurized dark, fueled by the slow, radioactive decay of isotopes or the grinding stress of orbital mechanics. As we absorb these possibilities, these hints of hidden vitality, we can feel our own hidden vitality. The process is just continuing within us, even as we rest. Your heart beats without thought, pumping blood through 60,000 miles of vessels. Cells metabolize, repairing, building, cleaning. Your immune system patrols. Your gut microbiome digests, synthesizes vitamins. All this happens in the dark, the interior of your body, requiring no conscious effort. The reaction's eternal hush of biochemistry proceeds in silence, enabling your existence. While you drift toward deeper sleep, the glymphatic system opens its channels, a nocturnal tide washing through the brain, clearing metabolic debris. The waste of wakefulness is swept away. Your neurons, like distant stars, pulse in low-frequency waves, delta, theta, the deep frequencies of repair. Each breath is a transaction, oxygen for carbon, a steady exchange with the atmosphere that sustains the slow burn of your cellular furnace. The deep void integration of the comet, journeying alone through interstellar space, reflects our own capacity for solitude, for rest. In sleep, you are alone with yourself, disconnected from external demands. This is not loneliness, but integration. The comet integrated its journey, its cold, its silence into its structure, preserving its integrity over billions of years through the vast, empty reaches between the spiral arms of the Milky Way. You integrate the day's experiences in sleep, processing, consolidating memories, balancing neurochemistry. The void is not empty, but full of quiet work. It is the space where the self is rebuilt, where the fragments of the day are woven into the tapestry of your history. In the stillness, you are not stagnant, you are becoming. Let us now consider the metal chemistry in greater detail, allowing the technical aspects to become almost musical, rhythmic recitation of elements and reactions. Nickel, atomic number 28, in the periodic table, sits between iron and cobalt. It has a moderate reactivity, forming compounds with oxygen, sulfur, carbon monoxide. Its electron configuration, Ar 3d28 4s2, allows for complex bonding, inviting molecule to cling to its surface. Iron, atomic number 26, more abundant and slightly more reactive, rusts easily in the presence of oxygen and water, but in the deep cold, it remains pure, a native grain. Both metal can act as catalysts, lowering the activation energy for reactions that would otherwise proceed too slowly to matter. They are the silent facilitators of change, the anchors for molecular transformation. The native metals in the comet exist because the environment of their formation was reducing, lacking free oxygen. In a protoplanetary disk, the inner region are too hot for metals to condense as solids. They remain vapor, swirling in the solar wind. But farther out, beyond the snow line, where temperatures drop below the freezing point of water, 150 Kelvin, 100 Kelvin, and even farther, where carbon monoxide and nitrogen freeze, metals can condense as grains, microscopic flakes of cosmic dust. They mix with ice, becoming incorporated into planetesimals, the building blocks of planets and comets. These grains are time capsules, preserving the chemical state of the early nebula before the stars had cleared the air. These metal grains, once embedded in ice, remain inert until warmth arrives. As the comet approaches a star, solar radiation penetrates the surface, warms the interior. Ice begins to sublime, first the most volatile, nitrogen, carbon monoxide, carbon dioxide, then water. As the ice disappears or becomes porous, metal grains are exposed to gases and perhaps to thin films of liquid water, mere molecules thick. Now, oxidation begins. Nickel reacts with water or carbon dioxide, releasing hydrogen or carbon monoxide. Iron does the same. The energy released is modest, exergonic, but sustained. Over days and weeks, it accumulates, raising the temperature of the surrounding ice, a feedback loop of gentle warmth. The nickel tetracarbonyl pathway offers an alternative. At temperatures around 150 Kelvin, nickel metal, exposed to carbon monoxide gas, can form this organometallic compound, NiCO. 4. Nickel tetracarbonyl is volatile, a colorless liquid that evaporates at low temperatures. It migrates through porous ice toward the surface or toward warmer regions. When it decomposes from heat or light, it deposits pure nickel in finer form as a dust and releases carbon monoxide back into the gas phase. This cycling of carbon monoxide on and off metal surfaces might enhance the efficiency of gas production, creating the subtle jets that push the comet along its path. Iron does not form a stable carbonyl under the same conditions. It requires higher temperatures or higher pressures. This explained the initial absence of iron emission in the spectra. Only nickel could be mobilized, at first, by the low-temperature chemistry. As the comet warmed further, approaching perihelion, iron vapor began to appear from direct sublimation or from the breakdown of iron-bearing minerals like olivine or pyroxene, heated to their breakdown temperatures. The coma chemistry therefore evolves as a temperature profile moves inward through the nucleus, revealing successive layers of composition, a chemical history, red in light, the sulfides. Another important component include troilite, iron sulfide, Fes, a common mineral in primitive meteorites. When troilite oxidizes in the presence of water or oxygen, It produces iron oxides and hydrogen sulfide gas, H2S. This gas has a distinct smell to humans like rotten eggs, though in space there is no medium to carry scent. The hydrogen sulfide might further react with other compounds or photolyze in sunlight, breaking into sulfur and hydrogen. The sulfur could contribute to the yellowish or brownish colors observed in some comets, the dust tails tinted by the chemistry of ancient volcanoes. The hydrogen, lightest element, escapes easily into space. The invisible halo surrounding the comet. These chemical details may seem intricate, complex, but allow them to wash over you, not as problems to solve, but as rhythms to sink into. Nickel, iron, sulfur, oxygen, carbon, each element playing its part in a slow, ancient dance. The metal ice symphony in slow motion plays on, notes separated by vast spaces, yet harmonious. The atoms in your own body were forged in the same stellar furnaces as these comet grains. The iron in your blood, the nickel in the comet's core are cousins, born of the same cosmic origin. Your breath slows further, notes separated by pauses, yet rhythmic. The catalytic quiet pulse of your heartbeat, steady, dependable, requires no thought. We return now to the journey itself, the trajectory through our solar system. 3K saw Atlas entered from the direction of the constellation Perseus. It was a traveller from the deep. Its velocity, relative to the Sun, was high, over 40 kilometers per second. This hyperbolic speed proved its interstellar origin. No object bound to the solar system moves so fast at such great distances. It approached from above, the plane of the planets, descending at a steep angle toward perihelion. The perihelion, closest approach to the Sun, occurred in January 2025 at a distance of about 0.77 astronomical units inside Earth's orbit, but outside Venus. It was a brief, intense encounter with the center of our world. At that distance, solar heating intensified, the flux of sunlight increased, surface temperatures rose, sublimation accelerated, the coma brightened, expanding to its maximum extent. Millions of miles of thin, glowing gas. For a few weeks, the comet was easily visible, even in modest telescopes, from Earth, a green-tinged ghost against the stars. Now, months later, it recedes, moving outward, back toward the cold. Its brightness fades, activity wanes. The jets weaken as the internal volatile reservoir deplete and as solar heating diminishes. With distance squared, the law of inverse squares, cooling the surface once again. Eventually, 3I Atlas will leave the solar system, escaping back into interstellar space on a different trajectory than it entered. Its encounter with the Sun bent its path gravitationally, and the non-gravitational forces from outgassing nudged it slightly. It will carry away less mass than it arrived with, having shed gas and dust as into the coma, some of which escaped entirely, some of which might, in eons, spiral inward and contribute to zodiacal dust, the faint glow seen in the twilight of Earth. But most of the nucleus remains, now colder, quieter, returning to its long dormancy between the stars, heading toward the constellation of Pegasus, or perhaps, further still, the trajectory, the arrival and departure remind us of transience. Things come, things go, even comets from other stars visit briefly, then vanish into the dark. Your thoughts, too, arise, linger, then pass. The day's events, vivid once, now fade into the past. The gentle volatile release of a memory surfacing, then escaping awareness is natural, expected. The comet does not mourn the gas it loses. It does not regret the mass it left behind. It simply continues. You need not mourn the day as it passes. You need not cling to its worries. Simply continue into the regeneration of sleep. The eruption's embrace of solar warmth was temporary but real. For a few months, the frozen traveler had felt heat, light, stirring its interior, awakening dormant processes, revealing its hidden nature to the universe. Now, warmth fades, cold returns, but the comet is not diminished. It experienced, it transformed, it released, and it continues, richer for the encounter. Even if now less massive, you must too embrace the day's warmth, its demands, its stimulations. You felt the light, you did the work. Now you release into the cool, quiet of night, not diminished, but ready for renewal. The atoms in your rest are as active as the atoms in the star. The silence is full. The sustained hidden glow of cryovolcanic activity suggests enduring energy sources not dependent on sunlight. This expands the habitable zone, the region around a star where liquid water could exist, to include locations far from the star where internal heat matters more than stellar radiation. We must look deeper into the physics of tidal heating, where the gravitational tug of a massive gas giant like Jupiter or Saturn creates a constant rhythmic kneading of a moon's interior. This friction, generated at the atomic level, converts orbital energy into thermal energy, keeping the oceans of Europa or the plumes of Enceladus liquid and active for billions of years. This insight multiplies the potential sites for life in the galaxy, suggesting that habitability is not a surface phenomenon, but a deep-seated geological process enabled by the dance of gravity and the slow, steady decay of radioactive isotopes like potassium-40 or thorium-232 sequestered in rocky cores. As we absorb these possibilities, these hints of hidden vitality, we can feel our own hidden vitality, the processes continuing within us, even as we rest. Your heart beats without thought, pumping blood through a closed loop of vessels that would wrap around the Earth twice. Cells metabolize, repairing, building, cleaning. Your immune system patrols, your gut microbiome digests, synthesizes vitamins. All this happens in the dark, the interior of your body, requiring no conscious effort. Consider the mitochondria, the ancient endosymbionts within your cells, generating ATP, the currency of life, through the electron transport chain. A series of redox reactions occurring across a microscopic membrane. The reaction's eternal hush of biochemistry proceeds in silence, enabling your existence. Your glymphatic system awakens in sleep, a specialized waste clearance system that hitches a ride on the pulses of your arteries, flushing the space between your neurons, washing away the amyloid beta and the tau proteins that accumulate during the day's thinking. The deep void integration of the comet, journeying alone through interstellar space, reflects our own capacity for solitude, for rest. In sleep, you are alone with yourself, disconnected from external demands. This is not loneliness, but integration. The comet integrated its journey, its cold, its silence into its structure, preserving its integrity over timescales that dwarf human civilizations. It has traveled for millions of years through the interstellar medium, ICM, bombarded by cosmic rays and high-energy protons, yet its core remains a pristine time capsule of a distant alien nebula. You integrate the day's experiences in sleep, processing, consolidating memories in the hippocampus, moving them into the long-term storage of the neocortex, balancing neurochemistry, resetting the sensitivity of your synapses. The void is not empty, but full of quiet work, a necessary and beautiful recalibration. Let us now consider the metal chemistry in greater detail, allowing the technical aspect to become almost musical, rhythmic recitation of elements and reactions. Nickel, atomic number 28, in the periodic table, sits between iron and cobalt. It has a moderate reactivity, forming compounds with oxygen, sulfur, carbon monoxide. Its electron shell structure, a 3D Fate Forces 2, allows it to share electron with ease, forming coordinate covalent bonds that make it a master of transition metal chemistry. Iron, atomic number 26, more abundant and slightly more reactive, rusts easily in the presence of oxygen and water. Both metals can act as catalysts, lowering the activation energy, the barrier to change for reactions that would otherwise proceed too slowly to matter. They provide a surface, a staging ground, where molecules can meet, orient themselves, and transform with minimal effort. The native metals in the comet exist because the environment of their formation was reducing, lacking free oxygen. In a protoplanetary disk, the swirling cloud of gas and dust that births a solar system, the inner regions are too hot for metals to condense, as solids. They remain as a hot vapor, ionized and turbulent. But farther out, beyond the snowline, the critical boundary where the temperature drops below 150 to 170 Kelvin, water ice becomes a solid, and even farther, where carbon monoxide and nitrogen freeze at temperatures near 20 or 30 Kelvin, metals can condense as fine grains, as cosmic smoke. They mix with ice, becoming incorporated into planetesimals, the building blocks of planets, and comets, becoming the seeds of future geology. These grains are tiny, submicron sized, yet they hold the magnetic history of their birth, aligned with the magnetic fields of the young protostellar disk. These metal grains, once embedded in ice, remain inert for eons until warmth arrives. As the comet approaches a star, solar radiation penetrates the surface. The photons, absorbed by the dark, carbon-rich mantle, warming the interior through conduction. Ice begins to sublime, first the most volatile, nitrogen, then carbon monoxide, then carbon dioxide, then water. As the ice disappears or becomes porous, metal grains are exposed to gases and perhaps to thin films of liquid water, mere nanometers thick, trapped in the pores. Now, oxidation begins. Nickel reacts with water or carbon dioxide, releasing hydrogen or carbon monoxide. Iron does the same, forming magnetite, Fe3O4, or hematite, Fe2O3. The energy released, the enthalpy of reaction, is modest but sustained. Over days and weeks, it accumulates, providing a gentle, internal heat that supports the glow of the cryovolcanism observed from afar. The nickel tetracarbonyl pathway offers an alternative, a more exotic, organometallic dance. At temperatures around 150 Kelvin, nickel metal exposed to carbon monoxide gas can form this compound, NiCO4, a tetrahedral molecule where the nickel atom is cradled by 4 carbon monoxide ligands. Nickel tetracarbonyl is volatile. It wants to be a gas, evaporating at low temperatures. It migrates through the porous ice, traveling from the core toward the surface or toward warmer regions. When it decomposes from heat or from the impact of ultraviolet photons, it deposits pure nickel in an ultrafine, highly reactive form and releases the carbon monoxide back into the gas phase. This cycling of carbon monoxide on and off metal surfaces might enhance the efficiency of gas production, acting like a pump, moving mass through the comet's interior. Iron does not form a stable carbonyl under the same conditions. It requires higher temperatures or much higher pressures, like these found deep within a planet's mantle. This explains the initial absence of iron emission in the spectra of 3I Atlas. Only nickel could be mobilized, at first, by the low-temperature carbonyl chemistry. As the comet warmed further, approaching perihelion, its closest point to the sun, iron vapor began to appear, not from carbonyls, but from the direct sublimation or from the thermal decomposition of iron-bearing minerals like troilite, heated to their breakdown temperatures. The coma chemistry therefore evolves as a temperature profile moves inward through the nucleus, revealing successive layers of composition, a chemical stratigraphy read in the lines of a spectrograph. The sulfides, another important component, include troilite, iron sulfide, Fes. When troilite oxidizes, in the presence of water or oxygen, it produces iron oxides and hydrogen sulfide gas, H2S. This gas has a distinct smell to humans, like rotten eggs, though in space there is no medium, no air to carry scent. The hydrogen sulfide might further react with other compounds or photolyze in sunlight, breaking into sulfur and hydrogen. The sulfur could aggregate into long chains of S8 molecules, contributing us to the yellowish or brownish colours, the interstellar soot observed in some cometary dust. The hydrogen, lightest of all elements, escapes easily into space, forming a massive invisible cloud of neutral hydrogen that can be detected in the ultraviolet. These chemical details may seem intricate, complex, but allow them to wash over you, not as problems to solve, but as rhythms, as a natural law to sink into. Nickel, iron, sulfur, oxygen, carbon, each element playing its part in a slow, ancient dance. The metallized symphony in slow motion plays on, notes separated by vast spaces, yet harmonious within the framework of the laws of physics. Your breath slows further, notes separated by pauses, yet rhythmic. The catalytic quiet pulse of your heartbeat, steady, dependable, requires no thought. It is a biological automation, as reliable as the orbital mechanics of a comet. We return now to the journey itself, the trajectory through our solar system. 3I Atlas entered from the direction of the constellation Perseus. It arrived with a velocity relative to the Sun that was far too high, over 40 kilometers per second, for it to be a local resident. This hyperbolic speed, with an eccentricity 1, proved its interstellar origin. It is a visitor from another star system, perhaps ejected by a giant planet in its own home system 3 billions of years ago. It approached from above the ecliptic plane, the plane of the planets, descending at a steep angle toward perihelion. The perihelion closest approach to the Sun occurred in January 2025, at a distance of about 0.77 astronomical units, placing it between the orbits of Earth and Venus. At that distance, solar heating intensified. The flux of sunlight, the energy per square meter, increased as the square of the distance decreased. Surface temperatures rose. Sublimation accelerated, creating the massive coma, a glowing envelope of gas and dust, millions of kilometers in diameter. For a few weeks, the comet was easily visible, even in modest telescopes. A faint, green-tinged ghost drifting across the background of the distant stars. Now, months later, it recedes, moving outward, back toward the cold. Its brightness fades, activity wanes, the jets weaken as the internal volatile reservoirs become depleted or refreeze as the solar heating diminishes. Eventually, 3I Atlas will leave the solar system, escaping back into interstellar space on a different trajectory than it entered. Its encounter with the sun bent its path gravitationally, while the non-gravitational forces, the rocket effect, from the asymmetrical outgassing nudged it slightly. It will carry away less mass than it arrived with, having shed gas and dust into the coma, some of which escaped entirely, some of which might, in eons, spiral inward as zodiacal dust, contributing to the faintest cone of light seen at sunrise or sunset. But most of the nucleus remains, now colder, quieter, returning to its long dormancy between the stars, heading back into the dark. The trajectory, the arrival and departure remind us of transience. Things come, things go, even comets from other stars visit briefly, then vanish. Your thoughts, too, arise, linger, then pass. The day's events, vivid once, now fade into the past. The gentle, volatile release of a memory surfacing, then escaping awareness is natural, expected. The comet does not mourn. The gas it loses, it does not regret. The dust it leaves behind, it simply continues on its path. You need not mourn the day as it passes. You need not cling to its worries. Simply continue into the regeneration of sleep. The eruption's embrace of solar warmth was temporary, but real. For a few months, the frozen traveller felt heat, light, stirring its interior, awakening dormant processes, revealing its composition to our instruments. Now, warmth fades, cold returns, but the comet is not diminished. It experienced, it transformed, it released, and it continues, richer for the encounter, even if now less massive. You too embrace the day's warmth, its demands, its stimulations. Now you release into the cool, quiet of night, not diminished, but ready for renewal. As you drift, imagine the comet, now far beyond the orbit of Neptune, its surface, once boiling with gas, now silent and dark, its internal fires. The chemical reaction between nickel and ice have slowed to a crawl, but they are not gone. They remain, a tiny, glowing ember in the deep dark, just as your life continues its vital, quiet work throughout the night. The universe is vast, cold, and seemingly empty, but it is filled with these hidden glows, these pockets of life and heat and awareness. You are one of them, and now it is time to rest. Let us turn now to the human wonder, the subjective experience of encountering such a phenomenon. Imagine being an astronomer, receiving the alert of a new interstellar object, the excitement, the rush to observe before it fades, writing proposals, competing for telescope time, the preparation, the anticipation, checking equipment, calibrating instruments, coordinating with colleagues across time zones, across continents, the night finally arriving when you point your instrument at the coordinates, the first light captured photons that have traveled from beyond our solar system, carrying information encoded in wavelengths, in intensities, in polarization states, the data flowing in, images, spectra, each one a gift, revealing secrets held for eons, raw numbers transforming into understanding, the analysis, late nights, coffee, equations, comparing models to observations, checking, rechecking, ruling out alternatives, the moment when the pattern clicks, when you realize cryovolcanism explains it all, the satisfaction of understanding, of adding one small piece to humanity's knowledge of the cosmos, this human side of discovery, the passion, the patience, the collaboration across countries and institutions, mirrors the collaborative processor within you, billions of neurons working together, creating thought, forming memories, generating consciousness itself, trillions of cells cooperating, maintaining your body, each one performing countless chemical reactions every second, exchanging signals, sharing resources, working toward homeostasis, toward balance. You're not a single entity, but a community, a symphony of living processes, an ecosystem contained within skin. The comet, too, is not monolithic, but a mixture of ice types, mineral grains, organic compounds, metal particles, all interacting, creating emergent behavior that no single component could produce alone, the whole exceeding the sum of parts, water ice providing structure, carbon dioxide driving activity, metals absorbing energy, transferring heat, organics darkening surfaces, affecting albedo. Together, they create something greater, a dynamic system responsive to its environment. The comparison to trans-Neptunian objects, those distant icy worlds orbiting far from the sun, strengthens our interpretation. Objects like Pluto, Eris, Makemake, Haumea show varied surfaces, varied compositions, some very bright, covered in fresh methane frost, reflecting 90% of incident sunlight. Others darker, with older, more processed surfaces, irradiated by cosmic rays over billions of years. Some show signs of past or present geological activity, features that shouldn't exist on bodies so small, so cold, so far from the sun's warmth. Pluto's vast plains, Sputnik Planitia, appear young, perhaps only millions of years old, requiring recent resurfacing, possibly from cryovolcanism or from ice convection, where nitrogen ice behaves like glacial ice on Earth, flowing, churning, erasing craters, creating smooth surfaces. The discovery that such small worlds remain active changed our understanding of planetary science, showed us that activity doesn't require massive size or internal heat from radioactive decay. Other mechanisms can drive geological processes in the cold, outer reaches of planetary systems. 3i Atlas resembles these distant worlds in composition, in behavior, suggesting it formed in the outer regions of its home system, where temperatures allowed volatile ice to condense, where the solar nebula was rich in carbon, in nitrogen, in oxygen, bound in icy forms, where metal grains mixed with ice, forming planetesimals in the cold during the chaotic early epochs of system formation. These outer regions of protoplanetary disks are storage zones for the system's inventory of volatiles, repositories of the lightest elements that couldn't condense. Closer to the star, most remain as small bodies, comets, scattered disk objects, Kuiper belt analogues, never accreting into planets, remaining as primordial remnants, time capsules preserving conditions from the system's birth. Some are ejected by gravitational interactions with giant planets during orbital migrations, during close encounters, becoming interstellar wanderers like 3i Atlas, cast out from their home, traveling for millions or billions of years through the dark between stars. The statistics of such ejections suggest that every star system ejects billions, perhaps trillions, of comets into interstellar space during its formation and early evolution, when giant planets settle into stable orbits, clearing out the remaining planetesimals. The galaxy, therefore, is filled with these wanderers, outnumbering by far the stars themselves, perhaps 10 or even 100 of these objects. For every star, most travel unseen, undetected, between the stars, dark, frozen, inert. Only when one happens to pass close enough to our sun do we notice, do we observe, do we learn. Each detection samples the diversity of planetary systems throughout our galactic neighborhood, giving us glimpses of worlds we could never visit directly. Your own mind contains multitudes of thoughts, memories, possibilities, most unseen, unexamined, drifting in the background of consciousness, neural patterns waiting to activate, connections forming and dissolving constantly. Only occasionally does one surface into awareness, into the light of attention, before fading back into the unconscious, into the vast darkness where most mental content resides. The comet drifting through the galaxy, mostly invisible, occasionally illuminated by a star's warmth, parallels the flow of consciousness. Most content remains dark, unactivated, potential rather than actual. Only a small fraction at any moment is active, expressing itself, being observed, being experienced. As we continue this meditation on ice and metal, on chemistry and light, on distance and time, we feel the gentle pull toward deeper rest. The cryovolcanic calm spreads through awareness like a mist, settling over everything. The ancient pressure surrender has already begun within you. Muscle tension releasing in waves, starting from your core, spreading outward. Thoughts slowing, their urgent pace diminishing. Breath deepening, becoming rhythmic, effortless. The silent jet harmony plays on, a background music you barely hear, fading further with each moment. The chemical depth piece invites you downward, inward, away from surfaces, towards center. The mantleless openness leaves you receptive, vulnerable in the best sense, to sleep's approach. Now we turn our thoughts to the deeper structures, the internal architecture that enables these quiet eruptions. The nucleus, perhaps a few kilometers across, maybe 5, maybe 10, is not uniform, but heterogeneous, complex in structure. Patches rich in carbon dioxide ice, alternate with regions dominated by water ice or by darker, less volatile materials, refractory organics, silicate minerals. Metal grains are not evenly distributed, but concentrated in certain zones, perhaps where they condensed in the original protoplanetary disk, settling through the nebula, accumulating in layers, or where they migrated during aqueous alteration, when liquid water briefly existed, dissolving, transporting, redepositing minerals and metals. These compositional variations create differential responses to solar heating. A region rich in metal and carbon dioxide heats quickly, the metal grains acting as heat sinks, absorbing photons, conducting warmth into surrounding ice, reacts vigorously, produces abundant gas, carbon dioxide, expanding from solid directly to gas, bypassing liquid phase, becoming an active source, a jet visible from Earth through our telescopes. A region poor in volatiles remains quiet, passively reflecting or absorbing sunlight, contributing nothing to the coma, to the observable activity, just sitting dormant until conditions change. The rotation brings different regions into sunlight, creating the temporal variations. We observe the brightening and dimming, the waxing and waning of activity as active patches rotate into view, then into shadow. The rotation period, perhaps 8 hours, perhaps 12, determines the time scale of these variations. The axis of rotation, its orientation, determines which regions receive the most heating over a full rotation. The interior temperature increases with depth at first as sunlight penetrates and warms. The outer layers then may plateau or even decrease if the deep interior remains cold, insulated by overlying layers by the low conductivity of porous ice. This creates a temperature profile that determines which ice is sublime At which depths? Near the surface, within millimeters or centimeters, carbon monoxide, the most volatile, with the highest vapor pressure, sublimates first, even at large distances from the Sun, beyond Jupiter's orbit, creating a tenuous envelope. Deeper, centimeters to meters below, carbon dioxide dominates, requiring more warmth, more solar flux, becoming active as the comet approaches closer to the Sun. Then water ice in the warmest regions closest to the surface, in direct sunlight near perihelion. Each ice has a characteristic sublimation temperature, a specific vapor pressure curve described by the Clausius-Clapeyron equation that governs its behavior predictably, mathematically, inevitably. The gases produced in the subsurface, carbon dioxide molecules, water molecules, carbon monoxide, percolate upward through porous ice, through interconnected voids, through cracks, through channels carved by previous eruptions. The flow is not uniform, but channelized, focused into vents, where permeability is highest, where the ice is most fractured, or where cracks penetrate deepest, reaching the warmest layers, where sublimation is most vigorous. This channelized flow explains the discrete jets rather than a uniform glow enveloping the nucleus. The pressure buildup behind a vent can be substantial, pascals becoming kilopascals, driving gas outward at speeds of hundreds of meters per second. Supersonic flow, expanding, cooling, freezing. The gas expands rapidly into the near vacuum of space, cooling adiabatically, temperature dropping, freezing into tiny ice crystals, nanometers to micrometers across, that scatter sunlight, creating the visible jets we observe, filaments of brightness extending from the nucleus. The dust, mixed with this gas flow, silicate particles, organic grains, metal flakes, is lifted, accelerated, ejected by gas drag. Some particles, too large, too heavy, return to the surface in ballistic arcs, falling back, redepositing. Others escape the weak gravity, joining the coma, the vast cloud surrounding the nucleus, or even leaving the system entirely, achieving escape velocity, becoming their own tiny interstellar objects. The mass balance of the comet is a story of loss and retention, transformation and preservation. Gas, once sublimated, escapes to space, irreversibly as lost forever from the nucleus. Dust partially escapes, partially returns, enriching the surface in non-volatile materials, in the heavier particles that couldn't escape over many perihelion passages. If they occurred, if this comet had returned repeatedly to some star, it would build up a dust mantle, centimeters, then meters thick, choking off activity, insulating the ice, preventing further sublimation. But through Atlas, on its first passage through our system, has no such mantle. Its surface remains responsive, pristine, fresh. Each photon of sunlight contributes directly to sublimation, to outgassing, to the sustained, gentle eruptions we witness from our distant vantage point. The thermal inertia of the material affects the response time to heating and cooling. Low thermal inertia means rapid heating and cooling, temperature tracking, the sun's position closely, immediately. High thermal inertia means slow changes, thermal mass, buffering against temperature extremes, smoothing diurnal variations, the porous ice with voids, with vacuum pockets, likely has low thermal inertia, heating quickly in sunlight, cooling quickly in shadow, within minutes or hours. This creates strong temperature gradients, steep curves of temperature versus depth, driving vigorous sublimation in the upper few centimeters or meters where the action occurs. Deeper than this, below the diurnal skin depth, the ice remains cold, unaffected by diurnal or even seasonal variations, preserving primordial cold from formation. These technical details, the physics of heat transfer, gas dynamics, sublimation kinetics, molecular diffusion, may seem distant from the experience of rest, from the purpose of this meditation. Yet they describe processes that occur without conscious effort, automatically, inevitably, given the right conditions, cause and effect unfolding according to natural law. Your own body operates on similar principles. Heat flows from core to skin following temperature gradients. Gases diffuse, oxygen inward to tissues, to cells, carbon dioxide outward to lungs, to atmosphere. Fluids percolate through tissues, through vessels, carrying nutrients, removing waste, all without your direction, without your awareness, all following natural law, physical law, chemical law, biological law. The comet teaches us that complex behavior emerges from simple rules repeated across vast numbers of molecules, of interactions. As we integrate these layers of understanding, scientific, experiential, meditative, we feel the weight of the day continuing to lift moment by moment. The primordial eruption flow within the comet, within you, follows its course inevitably, naturally, without resistance. The corrosion's soft energy transforms without violence, without force, gentle oxidation, gradual change. The catalytic quiet pulse maintains rhythm without effort, without intention, heartbeat, breath, sublimation, all automatic, all given. The global surface sigh happens now, a collective release of the day into the past, letting go of what was, accepting what is. The volatile memory drift carries away what you no longer need to hold, evaporating like carbon dioxide into space. The interior cosmic exhale empties the lungs of consciousness, releasing the breath you've been holding all day. The ice vent stillness between exhales lengthens, stretches, becomes the dominant experience Not the breathing, but the pauses. Not the activity, but the silence between activities. The sustained hidden glow of awareness dims further, retreating inward, contracting. You are becoming like the comet in its receding phase, moving away from perihelion, from peak brightness, activity waning, light diminishing, yet structure maintained, essence preserved, identity intact, just quieter, just darker, just more peaceful. The decline is graceful, natural, inevitable. There is no struggle, no resistance, only the gradual transition from expression to silence, from wakefulness to sleep, from day to night. The reaction's eternal hush begins to envelop all processes, covering everything, like snow, like ice, falling, settling. Chemical activity slows, reaction rates decreasing with temperature. Neural activity quiets, firing rates diminishing, synchronizing into sleep rhythms. The deep void integration approaches the merger with darkness, with silence, with rest. Let us drift now more fully into the abstract, into sensation, beyond specific facts, beyond measurements, beyond language almost. The eruptions on that distant surface has become a feeling of gentle release, pressure, then relief. The metal chemistry becomes the taste of peace, metallic, cool, clean. The spiral jets become visual patterns behind closed eyes, swirling, fading, phosphines, imagined or real. The coma expansion becomes the expansion of your awareness, diffuse, unbounded, no edges, no center. The subsurface pressure becomes the urge to let go, to surrender to what comes naturally, to sleep, to dreams, to nothing, everything dissolving into quiet, into darkness, into rest. The journey of 3i Atlas through our system was brief. A few months of visibility, of activity, of scientific observation. Now, as it fades, we are left with data, with images, with knowledge, but also with a feeling, a sense of having touched, however briefly, another world from another place. The comet carries forward most of what it brought. The gas is released, a tiny fraction of its total mass. Most remains frozen, intact, ready for the next encounter. You carry forward most of what you are. The day's experiences integrated, but your core, your structure, your essence remains. Sleep is not loss, but integration. Not ending, but transition. The comet does not cease to exist, and when it leaves our view, it continues in darkness, in cold, in silence, patient, enduring. You do not cease in sleep. You continue in darkness, in rest, in silence, renewing, restoring. The cryovolcanic processes taught us that even in extreme cold, even in apparent stillness, activity can occur, transformation can happen. So too, in sleep, though you appear still, inactive, within, processes continue, memories consolidate, tissues repair, balance restores, the comparison to Enceladus, to Europa, to Triton, reminds us that ice volcanism is common in our solar system and likely throughout the galaxy. Water worlds, ocean worlds, hidden beneath ice shells, erupting occasionally through cracks, releasing plumes that speak of hidden depths. The universe is not cold and dead, as it might appear, but alive, with quiet activity, with hidden warmth, with pockets of complexity scattered throughout. You too are not merely a surface, but depths, hidden warmth, complexity that continues even when outward expression ceases. The sustained glow from hidden activity dims, dims, dims. The comet, fading now, millions of kilometers away, receding toward the outer darkness. The distance grows, the signal weakens. Soon, it will be too faint for even the largest telescopes to detect. It will slip back into invisibility, back into the vast population of interstellar wanderers, unseen but present, traveling silently through the galaxy. Your own consciousness fades, fades, fades. The distance from waking grows. The signal of awareness weakens. Soon you will slip into invisibility, into the population of sleeping minds, unseen but present, traveling silently through dreams. The jets have slowed, nearly stopped. The coma contracts toward the nucleus. The brightness drops below detection thresholds. The comet is gone from our view, but not gone from existence. Your thoughts have slowed, nearly stopped. Your awareness contracts toward stillness. Your attention drops below detection thresholds. You're gone from waking, but not gone from being. And now we enter the final phase of our journey, the fade to silence, the return to the cosmic quiet from which all things emerge and to which all return. The words become fewer, the pauses longer. The science gives way to sensation. The facts dissolve into feeling, pure, abstract, restful, quiet, subsurface, awakening, reverses, becomes, settling, hidden, ice, whispers, fade, below hearing, gentle, volatile, release, becomes, retention, holding, metal-driven, serenity, simply, serenity, pristine, buried, breath, buries deeper, unreachable, cryovolcanic, calm, everywhere, everything, ancient, pressure, surrendered, silent, jet, harmony, becomes, silence, chemical, depth, peace, depth, and peace, mantleless, openness, open, completely, primordial, eruption, flow, slows, stops, corrosion, soft, energy, softens to nothing, catalytic, quiet, pulse, quiets, absolutely, global, surface, sigh, one last, sigh, volatile, memory, drift, drifts, beyond retrieval, interior, cosmic, exhale, completely, exhaled, ice, vent, stillness, perfect, stillness, sustained, hidden, glow, extinguished, reaction, eternal, hush, eternal, only hush, deep, void, integration, integrates, all boundaries, dissolved. The comet is space, space is the comet, you are rest, rest is you. No difference, no separation, only the field of being without edges, without center, the darkness so complete, so welcoming, the silence so deep, so full, the stillness so absolute, so peaceful. Nothing moves, nothing needs to move. Everything is as it should be, perfect, complete, at rest, ice, metal, space, time, all words, losing meaning, becoming sounds, vibrations. Then, not even that, awareness, so dim, so faint, barely a flicker. Then, not even a flicker, just the potential of awareness held in suspension. In the vast, in the dark, in the quiet, drift, deeper, further, darker, quieter, stiller, until there is no until, no before, no after, only this eternal moment of rest. The comet, somewhere, travels silently through the infinite dark. You, somewhere, rest silently in the infinite peace, both suspended, both complete, both free. And as you sink beyond the reach of words, beyond the touch of thought, into the deepest quiet, we remember that all journeys are circular, all endings are beginnings, and we prepare to meet you again when the cycle turns, when the awakening returns, when you drift once more into the quiet embrace of the cosmos, knowing that we are always here, waiting in the stillness, ready to guide you back to this deep rest.